Now you are given the following question. In the decomposition of 5-hydroxymethyl furfural, the rate constant K1, so let's bring out our parameters. K1 for the decomposition of 5-hydroxymethyl at 120 degree, temperature T1 is 120 degree, is 1.17 hour, 1.173 per hour, or 3.258 times 10 raised to the power of minus 4 per seconds. Why the temperature is either you use 120 degree or you use 393 Kelvin. Now is that, and K2, the second constant K2, is either 140 degree. I mean K2 is K2 was given as 4.80 hour at the temperature T2 is either 140 degree Celsius, this Celsius, or at 413 Kelvin. Now the question says that what is the activation energy EA in kilocal per mole and the frequency factor A in seconds for the breakdown of 5-hydroxymethyl furfural within this temperature range. Now within the temperature range, it means that you will find for T2 and then subtract it from what T1. That will give us the range. Now how do we actually find the constant, the activation energy rather, EA for T2 and that for T1? Is from the Arrhenius equation. What's the formula for the Arrhenius equation? The formula for the Arrhenius equation is you have log K is equal to log A minus EA all over 2.303, then you have ROT. Now we are going to split this for both constants and temperatures. Okay, so this becomes log, for the first one, which is the first temperature and constant, log K1 is equal to your log A. Your A still remains the same, minus EA all over 2.303 ROT1. Okay, now for the second temperature, it will be log K2 is equal to log A. A is constant for both, minus what? EA all over 2.303 ROT2. Now if you subtract both equations, what are you going to have? If you subtract this equation from this equation, what are you going to have? Now you are going to have, let me take it this way, you are going to have log, you have log K2. If you are subtracting K2 from K1, because we said T2 minus T1, so this becomes, subtracting this from this, it is what log K2 minus log K1 would be equal to. Now of course if you subtract this and this, it will give us what? 0, since they are the same. Okay, it will give us 0 since they are the same. So what are you left with? You are left with minus, this become minus EA all over 2.303 ROT2, then minus bracket minus, why? Because there is a minus here, then there's another minus here, minus what? EA all over 2.303 ROT1. Now you discover that this group here is different from this group. Now in our laws of indices, it was stated that whenever you have log A all over log B or let's say log A minus log B. Let me write it down. In our laws of indices, it was stated that when you have log A minus log B, it's still the same thing as log what? A over B in indices. So if I have log K2 minus log K1, it's still the same thing as what? Log K2 all over what? K1. Okay, this will be equal to, now what is common between everything here? You agree with me that this is minus what? EA all over 2.303 arrow T2 minus times minus is what? Plus EA all over 2.303 arrow T1. Now what is common between everything here? EA is common, 2.302, everything here is common apart from T1 and T2. So if we take everything out, you are going to have log K2 over K1 is equal to minus EA all over 2.303 arrow, this is constant. Okay, everything here is common, it's here, is here, is here, is here. Okay, so this will be brackets. What will be left here if you use this to divide this? Here will be what? 1 over T2. That's what will be left here. Then minus, if you use this and multiply this or divide this, EA here will cancel EA, 2, this one will cancel this, arrow will cancel arrow. So what are we left with here? 1 over what? T1. Okay, so that was how you got to this point. Now, have we gotten to this point? What is the next step that we take now? The next step is, let's factorize out or simplify what we have in that bracket. So that will give us log K2 all over K1 is equal to minus EA all over 2.303 arrow bracket. What is the LCM of T2 and T1? It is what? T2 T1 all over bracket T2 T1 divided by T2. What will be left here? To be left with T1. T1 times 1 will give us T1 minus, when this divide this, what will be left? To be left with what? T2 here. So that was how you got to this particular formula like this. Okay, that was how you got this particular formula. Now the next step now is to substitute in our parameters to get our EA, because we are asked to look for what? To look for EA. Let's substitute in our parameters. Now what you have here can also be written as log K2 all over K1 is equal to, now if you want this T2, because T2 is greater, to come here and then take this T1 to this side, what is it going to give to us? To give us something in such a way that when this one multiply, if you use this minus to, or if you use a minus to open through everything, it's going to give us something like this. Let's say minus EA all over 2.03 arrow bracket. If T2 comes this way, what is it going to give to us? Give us minus what? T2 plus T1 abi. Now all over T2 T1. Okay, all over the T2 T1. And then at the end of the day, if you use minus to multiply everything here so that they will fit in, this whole thing will give us log K2 over K1 is equal to, what are you going to have here? This becomes, if you use minus to multiply this, it gives us positive EA all over 2.30 arrow bracket. Use the minus to multiply this, it gives us what? T2 minus what? T1, because minus times minus will now give a positive T2, then minus T1 all over T2 T1. Now in the same vein, this is what we got at this point, right? There's a final formula that we got that we substitute in our values. Now in the same way, we may not want to follow this long procedure. We may not want to follow that long procedure. Just from here, we can decide to do something quickly. Just from this point here, we can decide to do something quickly. Now we know that this log k2 minus k1, right? We can write it as log. We said that will become k2 over what? K1 from logarithm is equal to. Now if this times this, it will give us positive, right? Minus times minus will be positive. So let me write it. This become minus EA all over 2.303 ROT2. Are we getting it? Then plus EA all over 2.303 ROT1. Now, for us to make this easier, let the positive come this way and the negative goes this way. So this becomes log K2 all over K1 is equal to, if the positive comes here, becomes EA all over 2.303 ROT1 minus EA, because this one is now coming here to give us negative 2.303 ROT1. Now at this point in time, if you carry EA out, and follow through the procedure again, it's going to give us log K2 all over K1 is equals to, what is common here? We said EA all over 2.303 RO is common. So what is left here? Here will be 1 all over T1, okay, minus here will be what? 1 all over T2 with what we did initially, okay. Now what is the LCM here? So this gives us log what? K2 over K1 is equals to EA all over 2.303 RO brackets. What is the LCM here? The LCM is T1 T2 all over. Here will be what? This divide this, it gives us T2 times this, it will be T2 minus this divide this. What is it going to give to us? T1. T1 times this is what? T1. So this will be the formula we are going to use instead of following that process, okay. So our formula now is log K2 all over K1 is equals to EA all over 2.303 RO brackets T2 minus T1 all brackets T1 T2. Now at this point in time, what can we do? Substitute in our values, okay. Now let's substitute in our parameters, okay. So this will give us log, what is K2? K2 is the time, which is in hours 4.80 all over K1 is 1.173. Now this, the time here does not matter because R will cancel R, so it's constant, okay. It's equal to, what are we looking for? EA, right? All over 2.303 times our R. Now our R has different values. R is the gas constant. Now when you are working with calories per mole, the R you use is 1.987. If you are working with ATM, it is 0.23 something. If you are working with Pascal, it's 8.341, okay, 0.02 something, okay. So this one that you are working with calories is 1.987. It's better you memorize the constants. So these brackets, we have T1, T2. The second temperature is what? 413 Kelvin minus T1 is 393 Kelvin. There you have divided by T1 is 413 times what? 393. Then when you simplify this, it's going to give us, when you simplify this, it's going to give us log this divide by this, it will give us 4.09 is equal to EA all over. Multiply this and this is going to give us 4.576. Then brackets, we have 413 minus 393 Kelvin. That will give us 20. Okay, so this will give us 20 all over 413 times 393 Kelvin. This will give us, I believe it will give us 162309. So 20 divided by that, 20 divided by 162309, going to give us 0.00 something. So therefore our log 4.09 first, log 4.09, this will give us 0.6117. okay, is equal to EA bracket 4.576 bracket 20 divided by this will give us 0.000123. okay, 0.00123. let me rewrite it again so that it will be visible. 0.00123. okay, now at this point in time, what can we do? We can cross multiply. Let this multiply this, so we have 0.617 times 4.576. that will give us, I use this to multiply this, please take notes, that will give us 2.799 is equal to, then use this to multiply this. If you use this to multiply this, it's going to give us EA. Then we still have 0.000123. okay, now at this point in time, what can we do now? Put in or multiply and then what? Divide to get your final answer. So that will give us, use this to divide that, this becomes 2.799 divided by 0.000123, so as to get your EA. okay, then this will be EA bracket 0.000123 divided by 0.000123. What I'm doing is to cancel out this so that we can get our EA. When this cancels this, our EA will become, so this will be 2.799 divided by 0.000123, and then our EA has a value of 22756.09. 22756.09. Your answers was supposed to be in kilocalories per mole. Now this is in calorie per mole. How do you convert from calorie per mole to kilocalories? Calories, it means you should divide by what? 1000. So divide it by 1000. What will be your answer? Take this one here, 1, 2, and then what? 3. Isn't it? Which will give us 22.756 kilocalorie per mole. Now if you approximate 22.7 to give us what? Let me quickly write it here. This will give us 23 kilocalorie per mole. Okay, 23 kilocalories per mole, and that was how they got that answer. So our EA now, which is the activation energy, is 23.23 kilocalories per mole. So that is the answer to that particular one. That is the EA. Now the frequency factor. Let's calculate the frequency factor in seconds. Now, how do we calculate the frequency factor A. First of all, let's take out the parameter for one of the temperature in seconds. The parameters. Now the temperature, we usually go with seconds. The one that go with seconds is the what? Kelvin. So that will give us our temperature in seconds is the one that will go with the Kelvin. And let's take 393 for instance. 393 Kelvin. Okay. Now, if it will go with Kelvin, what is the value for your K? Your K, the constant in seconds for the one of 393. This is what we are taking. Okay. So this gives us 3.258 times 10 raised to the power of -4 per seconds. Now, whichever temperature you take, you get the same answer. If you are taking T1, it means you must go with what? K1 in seconds. If you are taking T2, it means you must go with what? K2 in seconds. Now, what other thing do we need again? The formula for the Arrhenius factor is what? Arrhenius equation is log what? K is log A minus EA, okay, all over 2.303 ROT. Now this time we are using K1, so this becomes ROT1. Everything here is what? T1, K1. So substituting in, what are we going to have? We have 2.3, or not 2.3. This gives us log K1 is 3.258 times 10 raised to the power of -4 in brackets is equal to log A is what we are looking for minus EA is what? EA is the activation energy, okay, which we calculated as what? 23 kilocalories. EA is the activation energy, 23 kilocalorie per mole, which we can break down to what? 23,000 calorie per mole. Okay, so this becomes 23,000 calorie per mole divided by 2.303. Then we'll have R is a constant, which is 1.97, like I told you, 1.987 rather, for kilocalories. Now if you were given in atmosphere, use another values times the temperature in Kelvin is 393. So what are we now going to have as our answer if we simplify? So let's first of all find the logarithm of this. The logarithm of this will give us what? Now the log of this will give us minus 3.48. This will be equal to, we are looking for log A minus, now if you simplify everything here, punch it to your calculator, what is it going to give to us? Everything here, if you punch it to your calculator, is going to give us 12.78. okay, now to make log A straight out the formula, take this 12.78 from this side of the equation to this side. So what will it become? It will become minus 3.48 plus 12.78 is equal to log A. So at this point in time, you have this minus 3.48. This will give us 9.30 is equal to log A. Now to find log A, or to find A, if log A is equals to 9.30, A will now be the antilog, because if you find the antilog of this, it will cancel the what? The log. You find the antilog of this, so our A will be the antilog of both sides, which is 10 raised to the power of what? 9.30. Because the antilog, let me state it out. Find the antilog of both sides. Okay, if you find the antilog of both sides, this will give us 9. Antilog is 10 raised to the power of 9. Antilog is 10 raised to the power 10 raised to the power of anything, rather, not 9 alone. So this will be 10 raised to the power of 9.30 is equals to 10 raised to the power of log A. Antilog fights against log. So antilog cancel log. We have your A is 10 raised to the power of what? 9.30. And your A will be equals to. Now, 10 raised to the power of 9.30. What will it give to us? It will give us 19 point something something. Okay, that will give us 1.99 times 10 raised to the power of 9 seconds. Okay, now 1.99, let me write it here, please follow me. 1.99 times 10 raised to the power of that, what will it give to us? If you approximate 1.99, it will give us what? 2.0 times 10 raised to the power of 9 seconds. And that was how that answer was gotten. 2.0 times 10 raised to the power of 9 seconds. Thank you for your time.